The syllabus has homework 3 on it now. Let me blow that up a little bit. And homework 3 is due Wednesday, right before the Friday exam. That shouldn't impact you a whole lot because essentially things that I ask on the exam are things that you should know how to do from programming, from your programming assignments. And so as you're doing homework 3, you're essentially studying for the exam. In particular, for example, homework 3 is going to be parsing expressions. You can almost bank on the fact that I'm going to ask you to convert infix expressions to postfix expressions, which is a process that you're essentially engaged in homework 3. So you'll turn that homework in on Wednesday. It's extremely unlikely that I'll get it graded and back to you by Friday, but I'll give it a shot. I spent a long time grading some of your linked list programs over the weekend, the ones that had come in late. Mostly, yeah, exactly. It's just the subtleties of the errors are just remarkable. And some people I may have done a better job than others, mostly because I get tired after a while. So if you have questions about a particular problem or a particular score, why it didn't work or what was going on with it, by all means come find me. Thankfully, homework 2 is easier than homework 1. So, I mean, for example, I think only the cruelest of data structures teachers would ask someone to bubble sort a linked list. So, I plead guilty. I plead guilty to that. But my hope is by struggling a whole bunch with those nodes and linked lists and stuff in homework 1 that at least you have a pretty good idea of how to string these things together now. So homework 2, you're already working on it. Hopefully you've got it squared away. Was a relief. Homework 3 builds on homework 2, and this is to write an expression parser using your stacks. So you've got your stack class, and you're going to actually use it to declare 2 stacks, an op stack and a num stack. Yes?
Will you provide the stack class? Okay, so
it's your stack.
We can only like half start working on it until we get the stacks graded.
Well, if your stack isn't ready yet, you can use the STL stack,
Okay.
which by design I made the interface exactly the same.
Oh, okay.
So if your stack is not quite up and running, use the STL stack. I'll show you the syntax for how to use the STL stack today, in case you want to really get rolling on that quickly. And then once you're comfortable with your stack, you can simply replace the declaration instead of using the STL stack, using your stack. And then of course you've got to roll your makefile. So your makefile for your expression parser is going to have the stack stuff in there as well. Your implementation of this thing may be different from mine. My implementation, I need to modify number 10 there. That's not quite right. My implementation actually makes use of several classes that I constructed. My hope is today we'll talk about the architecture of the expression parser and give you at least some ideas about how to approach it. So we'll talk about just as a group discussion, we'll kind of talk about the organization of this program, and then what I'll do is I'll show you how I did it. That doesn't mean that's how you should do it. It's certainly, you can borrow ideas that I'm showing you, but you can also feel free to implement it in a completely different way if you'd like. So number 10 here, I need to update this a little bit because,
really quickly,
yeah.
I know we went over this once, but how do you make your executable called calc?
Yeah. Okay. Let me get in and re-demo my program.
Fine. Change the dot out to calc.
So
I'm not even sure if you need the dot. You need the O.
see this guy right here? There's a switch -O calc, and that renames the output file to calc instead of a.out.
Okay, so that's in the first build.
Well, okay, so you know when I type make like that,
Yeah.
the default is to use the first rule in the file.
Right, and then use whatever it needs.
And then, so when I type make, I do that. But if I, for example, just want to build getToken.o, I can do that. And it'll skip everything and just do that one line. But if I don't do that, then it'll just start with the first one, and then the first one will chase down all the dependencies and build the whole thing. All right, let me demo. So my calc program runs like this. I've showed you this already. 2 plus 3. I can do 2 plus 3 like that. I can do 2 plus 3 like that. So it's somewhat robust, but as you might imagine, it's not super hard to deal with that particular issue. You just want to eat blank spaces until you hit something. And you can do that with a simple while loop, and I'll talk about that. What's probably most of the complication in your program, or some of the complication in your program, is going to be dealing with this stupid minus sign, which can be interpreted in two different ways. There's 2 minus 3, which is just regular old binary subtraction operator, and then there's -2 plus 3, or whatever, or -2 minus 3. I mean, there are two different minus signs there. So we'll talk a little bit about that. And then if I'm done, I can just hit enter and the program will exit. Let's talk about big picture items here about how we might think about organizing this program. Let me get a new what are some big things that have to happen in the expression parser? Big components of this program. Go ahead, Luke.
You need to recognize if something's a number or an operator.
So I'm going to lift that up even higher and say that I have to parse the characters in the expression. Well, okay, so then I have to build some kind of parser that will look at the characters that are coming in off of the keyboard and do the right thing. What are some of the things that you can encounter in an expression? What are the big classes of things that are going to be coming in, at least relative to, remember how we decided we were going to do this? If we get a number, what do we do with it? Push it onto the num stack. If we get an operator, what do we do with it? Look at the op stack. If the thing on the top of the op stack is higher precedence, we execute it, right? And we just keep executing ops until we get one of lower precedence. Once the top element is of lower precedence, then we push the one that we have in our hand, right? That's the basic algorithm. Sounds really simple, right? What are the big things that we're looking for on this input expression, this collection of characters coming in off of the keyboard? I'm thinking of two big classes of things coming in. Yes. numbers and operators. So we need to reliably identify numbers and operators. Okay, what's the other big part of this program? Yeah, doing executing operations, right? I suppose there's sort of one. It might even be a slightly broader than that. It's not so much executing the operations, because to me, executing the operations occurs as part of this bigger thing that I'm thinking about. Sorry? Yeah, what is that process? That's the infix to postfix conversion.
Yeah.
So yeah, so I think the other big part is the infix to postfix conversion. And in there you have operator execution. Right, what I'm calling infix to postfix conversion is this process that I just described. Have a number, put it on the num stack. Have an op, run the op stack until the top element is of lower precedence, and then push it. That's the infix to postfix conversion algorithm. Inside that conversion algorithm, we have operator execution. Any other big elements of that?
This isn't big at all, but before 1, I would actually get rid of all the white spaces before doing anything else, because having white spaces in there would make the conditional statements a lot more harder, especially with a minus sign, I feel like.
Here you just eat white space all the time. Whether it's at the beginning, in the middle, or the end.
Ben was thinking eat all the white spaces out of the expression
First.
Oh, you could do that.
That's what I was thinking.
Yeah, yeah.
Because then the minus sign would be like, if the minus sign is, if right before it there's like nothing, then it's a negative sign if there's something before it. But if there's white space in there, it would make those conditional statements more complicated. So just clearing them out first.
So talk to me about how you're going to do this. This is actually going to lead to a really interesting aspect of the program. So, but I want to get there naturally. So let's talk about how you would do that. You want to get rid of all the white space first. How do you do that?
Just make a vector of characters, and just basically move your expression into memory.
Okay, so
I would just trade in, like input it as a string, then make a copy of that string going through element by element of the input string, skipping blank characters.
grab the whole expression into a string variable first. That's what you're proposing, right? Okay. When you do this, you give up a really important and very powerful and useful feature of CN.
Peak.
Meh.
I guess just right.
Peak is nice to have.
The ability to get like doubles parsed out of numbers and dots.
Right. If you turn CN loose on the front end of that input stream and there's a number there, it's going to grab the whole thing and turn it into that actual number, which is really convenient. Now, that said, you can still do what you're talking about here, and I will throw this out there for people that want to go this route. There is something in C++ called a string stream, which lets you take a string and turn it into a CN-like object, where you can start reading tokens from it, like numbers and characters and what have you, and ints. It's called a string stream, and instead of reading the characters from the keyboard, you take the string and you attach it to a cin-like object. And then the cin-like object will read stuff from the string like it was coming in off of the keyboard.
So just like file input, but on a string instead.
Yes, exactly right. And it's called a string stream. And it might be like S stream. I can't remember. In fact, I'll look it up for you.
Ben, to do your idea, wouldn't it be just as easy to keep track of like a previous operator so that you always know what came before the current character?
It's an S stream.
It is S stream, yeah. So right here, S stream. Okay, so
I like clever programming.
so you can bring the whole thing in at once. And if you go with the string stream idea, you can do what Ben's talking about. You can go through and get rid of all the white space and just have behind a nice pure visible character only string and parse that thing. Regardless, let's talk about, because frankly, what I'm about to talk about next will work in either the cin case or in the string stream case. Let's pretend that you've stripped out all of the white space and think about how we're going to parse this collection of characters. Okay, let's look at something like 2 plus 3. So that's what's coming in from the keyboard. I want to take advantage, whether I'm using the string stream or whether I'm using cin, I want to take advantage of those objects' ability to read in numbers and convert them to numbers, read in characters and convert them to numbers. So what do I have to do with this expression? And Josh was mentioning peak. So I'm thinking peak here. So let's talk about the mechanics of getting that 2, getting that plus, getting that 3. What do you want to do first?
We're peeking through a number, any number in the first, or a decimal point, really.
So we want to peek for a digit. Or a decimal point. Maybe. Anything else that would indicate a number is waiting to come in? That's going to be an op. Let's just leave it at that for now. So we peek for a digit character, a decimal point, or a minus sign. Detecting these things, then what do we do?
See it appropriately.
Can you instead do while cin to double x or cin?
Yes. You can get one of the downsides with that, or I don't know if it's a downside. So the idea here is to just do a while loop and eat numbers as you go along, cin x, cin x, cin x. There are a couple reasons why you don't want to do that. If you read a number, what's the next thing you're going to read? An operator. So that loop's only going to run once anyway.
But what if we did, is it returns false, so if there was an or, like, I guess it would have to be a character.
So the loop that you're trying to build a loop that automatically goes through the thing, and I promise that we'll get there with that loop. Essentially, what we're going to do is we're going to run a loop until we reach the end of the expression. So while the character is not an enter character, right, which indicates the end of the expression because the user presumably typed in some expression and then hit enter to get Cin to go or get the loop to go. As you can just keep parsing the expression until you see that \n, and when you get there, you know you're done. And think about how that's going to go. You're just going to go out there and peek and see, am I bringing in a number or an operator? And if I'm bringing in a number, I'm going to do that. And if I'm bringing in an operator, I'm going to do something else. Okay. And the other reason for, again, it's not that you can't do this. If you run Cin until it fails, it gets into this false state, and then you have to reset the false flag. You have to start to, because once Cin goes into a fail state, it stays in a fail state until you can wake it up again. And it's not that that's hard. I can't remember what the flag is, but there's some flag that will unset the fail state and get it going again. So peek for digit character, read a double, what have you. Otherwise, what?
Eat blank stuff.
Let's pretend that we've eaten blank stuff, although I can mention it here.
In our eater, you don't want us to like get rid of like letters and stuff. Above and beyond, you can enter complete nonsense, and we'll give you a number back.
Yes, exactly. Let's say we're going to assume that the user knows how to use it up to a certain point, and so we're going to say that the user doesn't enter letters. This does actually raise an interesting side issue, and that is, Maple does more, for example, than just parsing arithmetic expressions. It can parse expressions with variables in them. You might think about, as you're doing this program, what's actually involved in parsing an expression that has variables in it rather than just explicit numbers. Eat white space. What next? So peek, maybe. Oops, peek. Peek for an operator. The nice thing about the infix to postfix conversion algorithm is it can actually be run on the fly like this. I never have to go into the expression and then back up and then further in and then back up and so forth. I can literally do this thing on the fly. I can just throw these things away as soon as I'm done with them. I get a number, put it on the num stack, move on. I never ever have to come back to it. It's pretty cool that way. I mean, I kind of come back to it when I'm doing when I'm evaluating the operators, right? But I throw it on the stack, and that way it's saved in a nice place. So you peek for an op. I'm starting out with I think these guys, and then the minus sign, which I'll call unary minus. I'm going to start out with this set. Oh, and I'm also going to have you deal with this and this. This is fairly an unambiguous set. I eat white space. It's not a number. It's got to be one of these. Otherwise, it's just some kind of syntax error. So I see one of these guys out here. What do I do?
Grab it as a character. Make a stack of characters.
So we're going to grab the op character, and what are we going to do at that point in the program? We've got the op character in hand.
Look at its precedence, compare the precedence of the.
You go to the precedence table. This leads me to, I think, the next. Let's talk nuts and bolts. What is a precedence table, and how are we going to represent it internally?
Two-dimensional array.
It's a two-dimensional array, and two-dimensional arrays are indexed by integers, not by characters. So how do I find the right place in the precedence table? So I have a plus sign, and there's a star sitting on the op stack.
Something to compare the character with position.
So I need, yeah, keep going. So
Like a hash essentially.
it's kind of a hash. It's less complicated than a hash. So I've got a plus sign in my hand, and I've got a star on the top of the op stack, and I need to know, do I push or not?
I'm guessing you don't want us to do this as a giant web of these statements.
Right. I want you to go look at the precedence table and get true or false, push or don't push. And you're right, it's a two-dimensional array, and that is somehow incompatible with these characters that I'm throwing around.
Can't you just tell me which number represents which character at the top?
I need op codes, operator codes. In other words, I need every operator to have a unique code associated with it. What would be the simplest coding to give these operators?
0 to n.
0 up to however many, operators I have. So I could start off with something like plus is equivalent to 0, minus is equivalent to 1, star is equivalent to 2. Totally arbitrary.
Can these pre-processor things or
Yeah, we'll talk about it in a minute. That's for so I need some kind of correspondence between operators and the integers, the non-negative integers. Why? Because I'm going to use these. How am I going to use these numbers in the precedence table? As the indexes in the precedence table. So we're going to use these as indices in the precedence table. Now that question gets a little bit simpler. I've built a two-dimensional array of precedences. I've got a plus sign in my hand and a star on the op stack. Which entry do I look at?
0 to
0, 2. I go to 0, 2. If it's true, I push. If it's false, I execute. Simple as that.
Can we just hard code the table?
Hard coded in. Yep.
isn't that just a three-dimensional array though? Am I imagining?
That's a two-dimensional, right? So I've got the operator that I have in my hand.
Yep.
Yep.
No, I get it.
Okay.
I'm thinking of-
So if you look at David's book, you begin to see again. Let me get in here.
But do you never push the right parenthesis?
Yeah, but you can take care of all that in the precedence table, right?
Yeah.
So this array appears to be indexed by operator symbols, but that's not how you can't do that in C++, or not easily anyway. And so what you do is you build a code. Forget it. Okay, you build a code 0, 1, 2, 3 down the side, 0, 1, 2, 3 across the top. The incoming one is the one that you just got. The on stack one is the one that's currently at the top of the stack. You look, so I have plus in my hand and star on the stack. Do I push? Nope. Okay. I would recommend that you do this using C preprocessor stuff. Like that.
I'm guessing it was that you define the multiplication character as 0.
I'm not sure. I could make it 0 if I wanted to.
No, like star's character. Define star 0.
Oh, got it. Yeah, that would be a problem.
There's no sort of like.
No. You've got to use just some character string, words, constants, named constants. Ben.
What kind of variable type would we need if we wanted to more contain? So like the way that I was thinking to do this is you make an array that contains the operator elements, and then every time a check comes up, you go through that array, get its index, and then plug that into another one, so it's all automated.
Yeah, so what I would do is, in fact, what I did do is use a switch that works on a character. So is everybody familiar with the switch statement in C++-ish? It doesn't have to be a switch. It can just be a long sequence of if statements, if you like. If the character is plus, then op equals 0. If the character is minus, then op equals, and in fact, you wouldn't even say that. If the character is plus, you would say op equals add to try to keep it conceptually pretty.
Right, but so I was thinking you do for loop, right? So you have those 7 characters, 7 operations in an array, and then you say get the next character from the string that we're pulling in and go through the loop until it runs into a thing that is equal to itself, and then take that index and plug it into our table.
You could do that.
Okay.
Yeah.
So, and those are characters then? You make a character array of those then?
Yeah, you could do that. I suspect that you're going to have, it's 6 of one, half dozen the other. I mean, I think I did switch, op, and it's going to take me a case. I'm totally making this up here. Plus.
We want to learn how to switch words. Should we just look that?
Absolutely, yes. You should not rely on me. And then you would do something like opnum equals add break, and then case minus. And yeah, the minus sign is complicated. Complicates matters. We'll talk a little bit about that. The takeaway from this little section of notes is you need some correspondence between the operators and array indices, so that you can very quickly go from an operator that's in hand, an operator that's on stack, and dive straight to the right location in the precedence table to figure out whether you push or execute. Push or pop. Okay, so that was all for... Numbers are actually quite easy. Get a number, throw it on the stack. Ops have all of this baggage associated with them. Let's talk a little bit about distinguishing between Subtraction and unary minus. So I actually gave you the conditions whereby you can expect a unary minus. So go ahead and read that, the hint.
So could you just create a Boolean variable that you at the beginning initialize to, maybe true for unary minus, and then every time you pull a number, it would become false every time you pull an operator that isn't a right parentheses.
Yes, that's exactly what I did. There may be other ways to do it, but yes. So you get yourself a flag that you constantly maintain. And notice that you can assume that minus at the beginning of the input is a unary minus. So you've got this flag. I just called it bool unary minus, and I set it equal to true. And if I encounter a minus sign, there's this extra little branch. If I encounter a minus sign and unary minus is true, then it's a unary minus sign. Otherwise, it's a subtraction sign, and then I go ahead and I assign the opcode. So let me just put that in the notes to remind you guys.
So we're not letting them do like 2 times -6 without parentheses.
We are, or at least I did.
So you have to say after another operator.
Right, which is in the hint.
Oh, non-right parentheses is not just left parentheses.
Yes. Okay, so, but that's exactly right. And there are some parsers, I think Maple included, that will not do that. So their parsers is slightly more refined in the sense that 2 star minus 2 will fail. It'll give a syntax error. And that's simply designer's choice. So my parser lets 2 star minus 2 stand as 2 times -2, which will come out to -4. If you want to make your parser fail in that situation, that's fine. It's up to you. That's a design decision. So to distinguish to distinguish subtraction from unary minus, declare and maintain a Boolean flag called unary minus. And start it out as true. Start it out as true because if the first thing on the input line is a negative sign or a dash, we're going to treat that as unary minus. And then set it to false. When do I set it to false? After a number. And set to true after a what did I say? A non-right parenthesis? Is that how I said it? And then whenever you encounter a dash, you go check that Boolean variable and decide which one it should be.
So does that need to be in our precedent state?
It does. It does. Let's look at the example we were just talking about, 2 star minus 2. Which of those operators has to happen first? Unary minus. These unary operators have high precedence. They happen before star. They happen before slash. They're going to happen before any binary operator. They have high precedence. And you're going to, if you're so inclined, you want to do like sine or cosine or something like that, those are also unary operators and are also going to have high precedence. Think about ties. Sine of cosine of 2.
Precedence goes from right to left.
Yeah. Precedence goes from right to left. So plus, does plus push on to plus?
No, because we want to evaluate from left to right.
Right. Sine, does sine push on to cosine?
Yes.
Yeah. It's cool because the precedence table is still saving your butt. Right? It's still handling all of these various precedence weirdnesses. It's very cool.
Are we gonna have to deal with this on when we have a minus minus, or is that already captured in something?
Minus minus. So let's think about what happens with minus minus here. Minus minus 2. I'll write it up here. So there's a minus sign, and it's the first thing on the input stream. So how is it treated? Unary minus. Do I change the flag unary minus? No, because when do I set it to true? After a non-right paren. And that dash is definitely a non-right paren, so it's still true. Now I go out there and I see another minus sign, I bring it in, and it's still a unary minus. Okay. Does that second unary minus, what happens to it? Does it go on the stack or does it pop the stack? You had a 50-50 chance. It goes on the stack, right? And then we reach the end of the input and we do the second unary first, and then we do the first unary from right to left.
Is that generalizable to all unary operators?
Yeah. And there is actually, you may or may not know this, there is one binary operator that goes from right to left.
Mod? No, it's not.
The exponent, yes. And in fact, it was recently discovered that for the 20-some years of its existence, the TI-83 calculator had that rule wrong. It was literally just discovered like within the last couple of months, and TI has since fixed it in their newer models. They were doing exponentiation from left to right, and it's just wrong. And it was wrong for many, many, many years.
So you might give wrong answers.
It gives wrong answers, yes. And it's a big quagmire because there are a lot of textbooks that are based on TIs, and some of the textbooks actually just reverse the rule. And so you've got textbooks out there that say exponentiation goes left to right instead of right to left. But the official word from the math world is it goes from right to left. And so it is really, it's an interesting little mess that they've got themselves into. Yeah.
So wait,
But TI, to their credit, TI, once it was pointed out to them, they backed off and they said, yeah, we're wrong, and started fixing their calculators.
So that's like 5 squared cubed.
Yes, 5 to the 2 to the 3.
So you're supposed to first evaluate.
You're supposed to do 2 to the 3, 2 to the 3, and then 5 to whatever, 5 to the 8th. Yeah. Yeah, little known fact. Okay. Let's. So my parser. Numbers and ops I call tokens, and that's a fairly common usage in computer science. So these are tokens. And what we want to do, or what I did anyway, was I wrote something called a tokenizer. So it goes through the list of characters which have no a priori structure at all other than just a list of characters. Right, to the computer, to the program, there's no a priori structure to this incoming stream of characters. So what do I have to do? I have to break this thing up into numbers and operators, tokens. And the process of breaking something up into these important tokens is called tokenizing. So I wrote a class that tokenizes the input stream. I have another class that manages all the information associated with ops. The op codes, the how to execute an op, right? Because to execute a binary operator requires you to pop two numbers off of the num stack and do something and then push it back. But a unary operator, you just pop one number off of the num stack, do something to it, and push it back, right? So I have two main classes for the expression parsing. A tokenizer, which I called getToken, and I can't remember, I think I just called this operators. You are not bound by my approach. I'm just giving you a one way of doing it. And then I had a third class. There's the stat class. From homework 2. And I'm going to use my stat class for both numbers and operators. I can't remember, are your stacks doubles this week? Are they holding doubles? Yeah. One advantage, you can decide whether you want to do this or not. The op codes are clearly integers, right? And yet I want to be pushing op codes onto a stack. You can decide whether you want to have two stat classes, one for doubles and one for ints. Or you can just push the opcodes onto your double stack and treat the integers as doubles. Either one is fine with me. If you go that latter route, then you're just dealing with a single stat class that holds doubles, and you're throwing numbers on there on one stack, and you're throwing opcodes on the other on the op stack. Ben?
Oh, the way you do that's exactly clear is to actually define, like, say, double or int before your variables if they could be ambiguous, and then it picks the correct class definition.
Right, and if you wrote your stack, did I make you use a type def?
Yeah.
So if you wrote it carefully using the type def, then it's really easy to write this new stat class that holds ints, right? Just copy stack to stack int or int stack or something and change the type def at the top, and you should be done. It's a lot of overhead for not much gain. So if you want to do it, go for it. There's no reason to push characters unless you really want to. If you really want to keep the characters, right? You can push the characters onto a character stack. You can push the ops onto a character stack. Where you're going to run into trouble with that is when you start parsing things like sine and cosine, where they're not represented by a single character, but rather by 3 characters. So I think in the long run, you're better off just pushing opcodes. If I have an addition, I'll just push a 0. If I have a slash, I'll just push a 4. And I'm going to know that from my defines, I'm going to know which is which. This is not for the faint of heart, this program. I would definitely get on this early. I think we're done. I'll show you a little bit of. I'll show you some of my headers, and we'll talk through my main program on Wednesday so that you have an idea of what some of the moves are. Until then, I look forward to seeing your stacks tonight, tomorrow. 3 days from now.